2 trachea, approximately 1.5 meters long. Power cord, sample clamp. Sample support rod, 1 piece of wire mesh, and 1 piece of steel plate. An ignition spray gun. 1 butane can, 1 glass barrel. Prepare oxygen and nitrogen cylinders, add pressure-reducing valves. Connect the trachea to the corresponding gas interface at the back of the device. Secure with clamps. It is best to reinforce the trachea with clamps or wire as shown in the diagram to prevent air leakage. Then assemble the igniter. There is a protrusion on the gas cylinder. There is also a corresponding gap at the bottom of the igniter. Insert the igniter into the top of the gas cylinder in the middle. Push the yellow metal part on the igniter with your thumb to rotate it. Displacement occurred in the upper part. The two will be connected and clamped together. Then turn the yellow knob to control the gas. The copper tube part can be bent. Open a little yellow knob. The plus sign is open, allowing for adjustment of flame size. Ignition. The flame is 1 to 2 millimeters. Close the gas tightly when not in use. Assemble support rod, uniform air plate, wire mesh. There is a threaded inner hole at the bottom of the exhaust base. First, rotate and screw the support rod into the inner hole. Place the uniform air plate at the bottom. Then put the wire mesh on top as well. Put the wire mesh card in this place. The screws on the fixture can be adjusted according to the sample being clamped. Place it at the top of the pole. Wire mesh has a certain degree of extensibility and is prone to deformation. You can make a small incision inside the wire mesh. Continue to clamp the net downwards. Place the fixture on top. Then put the glass tube on top. An 85 mm glass cylinder is placed on the base step. The regular 75 mm glass tube is placed directly to the bottom. Power on. On the left is the current oxygen concentration, which is the real-time oxygen concentration inside the pipeline. If there is no calibration after startup, this value is meaningless. The combustion time and whether it exceeds 50 mm are used for observing and recording experimental data. 50 mm is a click to confirm function. Just need to observe for presence or absence. On the right is the control function section. According to the experimental process, they are voltage regulation, calibration, startup, and manual stop. The timing function is to record the combustion time, not available in non-experimental state. Click on timer. Time cannot be calculated. Only display adjustment completed above the minus key. Start the experiment. The timing function can only be clicked. The printing function is an optional configuration, which is not included in the standard configuration. Parameter setting interface. Click to enter and clear history records. Clear all saved data. Nitrogen solenoid valve control and oxygen solenoid valve control are separate switches. The plus and minus signs of the solenoid valve respectively control the forward and reverse rotation functions of the internal motor. The diameter of the mixing cylinder can be selected between 75 and 100. Click on the number section and enter. Conventional 75 mm. The standard oxygen concentration refers to the actual concentration of oxygen in an oxygen cylinder. Pure oxygen is about 100. Then the oxygen concentration deviation is corrected, and there is no need to modify it. Then save. Return to the collection interface. The historical data in the directory above. Click Save. The experimental data will be saved to historical data. The experiment name can be set arbitrarily. Network settings do not need to be modified. Next is verification. The current analog value is the digital signal of the oxygen sensor in the state of pure oxygen supply. If the simulated value remains stationary or is zero, explain the need to replace the oxygen sensor with a new one. The oxygen and nitrogen switch is a branch valve switch. Automatic verification is used to verify the accuracy of equipment. Turn on the main switch of the oxygen cylinder. The right dial of the pressure reducing valve displays the internal pressure of the gas cylinder. The one on the left is the output dial. Control the output pressure through the valve in the middle of the dial. Adjust the pressure to around 0.2 to 0.25 megapascals. The same applies to nitrogen cylinders. Open the gas cylinder and adjust the pressure to around 0.2 to 0.25 megapascals. The maximum output pressure should not exceed 0.4 megapascals. Return to the collection interface and start the experiment. Click on the pressure adjustment button. The current status is displayed on the minus sign button. Please adjust the pressure reducing valve. Don't worry when the knob can't be turned. Pull the valve outward. The valve is equipped with a locking setting, which can be pulled outward to unlock. Rotate the pressure reducing valve, open clockwise and close counterclockwise. Adjust it to between 0.1 and 0.15 megapascals. The pressure reducing valve must not be fully open to prevent damage to the equipment. After adjustment, press and lock the pressure reducing valve to prevent accidental contact. Click again to turn off voltage regulation. Click on Calibration. Calibrate oxygen, so only the oxygen valve automatically opens and adjusts automatically. Nitrogen is in a closed state. Calibration automatically introduces oxygen into the system. Controlled by vector flow meter. The flow rate is automatically adjusted based on the diameter of the filled glass cylinder, and automatically calibrate the incoming oxygen. Calibration ends automatically, oxygen valve closes automatically. Next, set the target value and modify it by adding or subtracting a sign. You can also directly click to set the oxygen index. Enter the numerical value and click on the space to confirm. Then click on Start. There is a display above the minus sign button, and the current status is to adjust oxygen. Now displaying to regulate nitrogen gas. The nitrogen valve will automatically open. The device runs automatically, just click Start and wait. As shown above, the device has entered the adjustment ratio state. The current oxygen concentration will approach the set mix concentration. This process takes about 2 to 3 minutes. During the adjustment process, the values may drift between the set values, may increase or decrease. It will take about 3 minutes to adjust. After the current oxygen concentration value corresponds to the set value and stabilizes, the current status on the minus key will display adjustment completed. Remove the glass tube. Pick up the sample holder and prepare the sample. The screws on the fixture can be tightened or loosened. There will be a gap at the top for attaching the sample to the furniture. Then tighten the screws. Make the sample vertical. Place the sample. Place the glass tube properly. Turn on the igniter and ignite. Bend the pipeline at a certain angle. Do not tilt the tank, as it may cause the fire to extinguish or unevenness. Ignite the top of the sample bottle until the sample is ignited within 30 seconds. Click on Timer. Timing can only be clicked after the display adjustment is completed. Another method is to mark the sample with a 50 mm marker line from top to bottom. Determination of flame reaching the marking line. By observing, you can click yes or no. Observe the natural flame of the sample extinguishing. Click the timer again. The timer will stop. Click Save. The set oxygen concentration, recorded combustion time, and whether the combustion length reaches 50 mm of data. Click OK to save. If the oxygen concentration value needs to be changed, you can click on the plus or minus sign to directly replace other data. For example, adding 0.5%. The device will also automatically operate for control. You can also directly input the oxygen concentration value. For example, 30. The device automatically recognizes and adjusts the concentration value. After the adjustment is completed, replace the sample with a new one and conduct another experiment. Just close the two gas cylinders directly. After closing it, it was found that the pressure-reducing valve of the bottle did not decrease. Just open either end and release the gas inside the tube. Click on the pressure-regulating solenoid valve to open, and excess air will be released from the glass barrel. The pressure-reducing valve will reset to 0. Close the pressure regulator again. Shut down.